Who started the broadcast? It's only quarter to.
Not me.
I didn't touch anything.
Not me.
I don't know if there's a way to. Good afternoon, everyone. Welcome to the DBA virtual chapter. My name is Sharon Dooley, and I'm the moderator today. We're honored to have speaker Luis Vargas from Microsoft, and he's going to be talking about the enhancements to the always-on technology in SQL Server 2014. I'd like to thank our sponsor, Dell Software, who sponsors our chapter for a whole year and makes it possible for us to give things away and things like that. I want to call your attention to SQL Saturday. The slide looks kind of messy because I was editing in a rush. But as you can see, there are a lot of them happening both in North America and internationally. They're free one-day training events. They're like a mini conference. You may be asked to pay $10 for lunch. That's the only charge there will be. There's usually vendors and some swag to be given away. And lots and lots of topics. We at the SQL Saturday in Philadelphia, we usually have 6 tracks with 6 presentations in each track. And so you can imagine the things you can learn in a single day. Check out www.sqlsaturday.com for an event near you. They're happening all over the place all the time. We are a part of PASS, an independent nonprofit organization run by and for the community. And it's the only professional association totally devoted to SQL Server. And therefore, from my point of view, it is the best professional organization. It's been doing this mission since 1999 when it was founded by Microsoft, and Computer Associates, and it grows by leaps and bounds. It has expanded globally, and the membership is free. All you have to do is go to SQLpass.org, sign up. You can sign up for mailing lists as well. A call to your attention, the upcoming Business Analytics Conference, which is happening May 7th through 9th in San Jose, California. Should be a lovely time of year to be in that part of the country. And there is a discount code, but be quick because it won't last forever. And I said we're the database administration virtual chapter. We meet twice a month. On the second Wednesday of each month, we meet at noon Mountain, and the fourth Wednesday at noon Eastern. There are 2 months where we usually only have one meeting, and that's November, when at fourth Wednesday usually runs right into United States Thanksgiving, and December, when fourth Wednesday usually runs right into Christmas. But check us out. Our website is dba.sqlpass.org. You get mailings from me with all the information about our meetings if you're on our mailing list. If you're not on our mailing list and want to be, go to sqlpass.org and add that to your list of memberships. This is part of a SQL Server 2014 webinar series. They've all been hosted by the virtual chapters, and the presenters are from Microsoft, and we're glad that they are making this contribution to our virtual chapters. And that's all I have to say. I'm going to turn the meeting over to Louis. I will make you a presenter, Louis, and I will, wait a second, before I do that, I better stop. Okay, I've stopped showing my screen. Make Louis a presenter. And Louis, you can show your screen and start doing your thing.
Thank you, Chad. I think that you can hear me now. So let me share my screen. Okay, so I'm hoping that you can see my screen now. So my name is Luis Vargas. I am a program manager lead on the SQL Server team. So I work on high availability. So in my team, we have what is called Always On. And for the people that are not familiar with Always On, I'll give some background on it. The team also owns a couple of other things. We own running SQL Server in Windows Azure virtual machines. So for you who are not familiar with this, we support running SQL Server in the Microsoft Cloud in Windows Azure virtual machines. So you can go into Windows Azure and you can provision virtual machines that have SQL Server pre-installed, right? So very quick way of going and trying a new version of SQL Server. So actually, we released SQL Server 2014 last week, and we have it already available as an image in Windows Azure. So feel free to go and try it. In the team, we also own what we call in SQL Server hybrid scenarios, and this means the scenarios where we bring value from the cloud to our on-premise customers. So if you are using today SQL Server in your organization, there are multiple services that you can benefit from the cloud. Things like taking backups, for example, into Windows Azure and keeping them for archival reasons. You can keep replicas for your always-on configurations, for example, in Windows Azure as well, so that you can recover your SQL Server in case of a disaster. And there are a couple of other scenarios. So anything that involves providing services from the cloud to on-premise customers is also part of what we do in the team. I have 10 years of experience, so I've been a program manager at Microsoft for 6 of those. And before that, I was a developer in financial services. So moving into the presentation. So it seems that around 30% of you have already used Always On. It seems that 70% haven't had experience yet.
Louis, excuse me. Excuse me, the attendees say you need to increase your microphone volume.
Okay. So let me try that. Can you hear me better? Okay, so let me try that. Just raise the volume a little bit. Okay, so looking back to SQL Server 2012, so for you who don't have the context yet on Always On, so in 2012, we started looking at high availability with regards to what we want to do for that release and the next releases. So at that point in time, we already had some solutions. You may be familiar with those. We have database mirroring. We have SQL Server clusters. To some extent, we have log shipping. People were using this for different high availability and disaster recovery scenarios. And we took a look at what are the dimensions that we want to make sure that we satisfy from that point onwards, and what is the best way to solve these dimensions. So the first thing that we look at is we want to ensure that we have a solution for high availability that is 100% reliable, that is able to detect failures, that it doesn't have false positives or false negatives, that is able to stand multiple failures. So in the system, you may have multiple failures. For example, one or more SQL servers may fail. Connectivity between the SQL servers may fail. Even your DNS, for example, may fail, and there may be some way for you to recover from those failures. We wanted a solution that is integrated. So again, in the past, before SQL Server 2012, if you wanted to achieve high availability and disaster recovery, then you needed to mix solutions. So for example, you would use database mirroring for high availability, and then you could use log shipping for disaster recovery. Or you could use SQL clusters for high availability and database mirroring for disaster recovery. So we wanted to make sure that we have a single unified solution, right? So that you don't only have to configure, manage, and monitor this solution. The other thing that we wanted to do is make sure that you have a flexible solution. So we know that many of our customers today don't have shared storage environments, so many of our customers don't have SANs, for example. Right? They only have servers with direct attached disks, and we wanted to provide a high availability technology for them. At the same time, we know that some of our customers have already invested heavily in SANs, and we wanted to be able to still support those scenarios and provide value for customers who have already done those investments.
Louis,
finally,
excuse me again. The attendees say that it's still hard to hear you, and that the audio isn't clear, and that they would like you to speak more slowly.
Okay. So let me see if I can improve my mic a little bit. All right, so let me speak a little bit slower here. Finally, we wanted to ensure that we have an efficient technology, right? And what this means is being able to use your high availability hardware for something else than just waiting for a failover to happen. So we know that many of you, will invest into having one or more secondary servers for your high availability technology or your disaster recovery technology. And we want to make sure that you can use those hardware resources for something else. And we'll talk about what are the things that you can do with Always On and how you can use this hardware for. Final thing, we want to guarantee that the failover happens seamlessly and fast, right? So the way the applications will be able to run faster is if we can guarantee that the failover happens fast in the system. So we'll talk about all of these things into more detail in the next slides. All right. So looking into always on. So always on is the marketing term that we use in SQL Server to refer to the high availability technologies that we have. This includes two technologies. So this includes failover cluster instances. Right? People also know these as SQL clusters. Right? And failover cluster instances provide high availability for servers. So this provides high availability for your full SQL Server instance. Right? And this is very useful in consolidation scenarios. If you have tens or hundreds of databases, for example, and you want to guarantee that all of these hundreds of databases fail over at the same time, you have a simple solution with failover cluster instances. Also, if you have many dependencies outside of your user databases, for example, large number of aging jobs or large number of SSIS packages, and you want to guarantee that all of these fail over together with your user databases, then failover cluster instances is a good solution for that. Now, failover cluster instances requires shared storage. So either you can use a SAN, right? and some of you may already have some of these in your environments, or starting in SQL 2012, you could use an SMB share, right? The only consideration is failover cluster instances depend on the storage redundancy. So we assume that the shared storage that you're using has some storage redundancy. We're not going to replicate any data for you in the case of SQL clusters. Failover takes minutes. How many minutes? It can go from 1 to a couple of minutes. The reason why this takes this time is because we need to restart the SQL Server instance in case of a failure. And restarting the SQL instance means that every database in the server needs to go through a recovery stage. Right? And this recovery stage can take some time because we need to redo every transaction that has been committed, and we need to roll back transactions that haven't been committed. We'll talk about in the next slide about some of the improvements that we did, in case you're not familiar, or how you can reduce the failover time for SQL clusters. And then with SQL clusters, you can have multiple nodes, right? So you can have, depending on the version of Windows that you're running, in Windows 2012, we support up to 64 nodes. Before that, we supported 16 nodes, right? And then these nodes are passive. So what this means is with SQL clusters, these nodes basically become active only after a failover. Before that, you cannot use them. Now, we introduced a new technology called availability groups. It seems that some of you are already familiar with it. And what availability groups provide is high availability for groups of databases. Right? So with an availability group, you can add one or more databases into the availability group, and we'll guarantee that all of these databases fail over together. Right? So if SQL Server becomes unavailable because you lose power, for example, or you lose connectivity to that SQL Server, all the databases in the availability group will fail over together to a different SQL Server. Availability groups do not require shared storage. So with availability groups, all you need is to have your local attached disks to each of your servers. And what we do is we synchronize every transaction that happens on the primary to all the secondaries in the availability group. And the way this works is that every log record that is written on the primary associated with your transaction, we send it over the network to the secondary replicas. Right? And then those replicas, when they receive these log records, they basically substitute the log that they have with the new log. Right? And then there's a separate process that applies those transactions to the physical pages in the database. Right? So we're basically guaranteeing a physical copy of your databases between the primary and the secondary replicas. And because of this, failover takes seconds. So in the case of availability groups, these secondary replicas have hard copies of your databases. And then at failover time, when we need to failover, all we have to do is pretty much change a flag in the system where we tell SQL Server, you can start accepting connections on this new primary and stop accepting connections on the previous primary. And from that point, connections can start executing transactions on the new primary. How many seconds? Again, this depends on a couple of things. This depends on the amount of workload that you're running at that particular point in time when the failover happens, plus what are the capabilities of the I/O subsystem on the second. But just giving you a rough number, based on what the customers that we're seeing, using the feature over the past now almost 4 years, this can go between 15 seconds to 30, 35 seconds, depending on the workload and the capabilities of the secondary. You can have multiple secondary replicas. So in 2012, we supported 4 secondaries. In 2014, we support 8 secondaries, and the secondaries can be active. Right? We'll talk about what active means and what are the things that you can and cannot do on the secondaries in the next slide. All right, so for people who are not familiar with the investments that we did in SQL clusters in 2012, so we had some very exciting investments. So if you haven't looked at this, I invite you to look at them in more detail. The first one is multi-site clusters. So people who in the past have created clusters across different sites, for example, for disaster recovery, they know that they have to go and stretch a virtual LAN and involve some complexity associated with that. Now, since 2012, you can create these clusters across subnets, and all you need is basically communication, TCP/IP communication between the cluster nodes, and the ability to basically join them to the same domain, or you don't need to have to stretch a virtual LAN. MDB and local disk. So many customers wanted to keep MDB locally just because of improved performance. So you can have your SSD drive, for example, locally, and you can run MDB there. So better performance by keeping it separate in the SAN. Also better utilization of your SAN. You probably don't want to spend your SAN on temporary storage. Indirect checkpoints. So I talked about how you can specify more predictable recovery times. So indirect checkpoints allow you to specify how often to apply direct pages. These are pages that have been changed in memory but not applied yet to disk. How often to apply it to disk. And by specifying these time intervals, you can basically define what is the maximum amount of recovery that your database will have to do in case of a failover, right? Because you're reducing the amount of direct pages that will have to be redone and applied to the pages. And final one is flexible failover policy. So since 2012, you can specify 5 levels of failure that will cause an automatic failover. Right? And the lowest level is the SQL Server service is down. Right? And you can go into higher levels. For example, level 4 starts considering out-of-memory exception. So if your SQL Server is running out of memory continuously, level 4 will fail over that to a different server. Level 5 looks into even more specific things like if there are unresolved deadlocks that SQL Server can not resolve, or if there are internal exceptions, for example, within the server, that will cause an automatic failover. So this allows you to specify how sensitive you want your application to be to failures, right? So interesting enhancements. In case you're not familiar with them, please look into books online, the SQL Server documentation, and you can learn more about each of these. A quick overview of our availability groups before we jump into SQL Server 2014. So as I mentioned before, it allows you to specify multiple databases that will fail over together. You can have multiple secondaries. Again, in 2012 it was 4, in 14 is 8. Compression and encryption, so all the transactions that we send, or more specifically, the log records of those transactions that we send between primary and secondary are compressed and encrypted. You can specify manual or automatic failover for every secondary. What this means is if you specify manual failover for a secondary, that means that you can only manually failover to that secondary. This is useful, for example, if you're going to patch your primary server, right? You want to failover first, and then you can manually patch the server and then fail back to that server after it is patched. Or automatic failover, So if you specify a secondary for automatic failover, that means that it will become the primary automatically in case that the previous primary becomes unavailable. For example, because SQL Server loses power. One example. Similar to SQL clusters, you can specify flexible failover policies. Right, the same 5 levels applies there. And we have a very interesting feature called automatic page repair. So if you're not familiar with this feature, what this allows you to do is when SQL Server is trying to read or write a page in disk, if it detects that the page is corrupted, right, so we have a hash, a digest associated with each of these pages, and if we detect that a page is corrupted, then that replica will automatically broadcast a request for that page to all of the other replicas in the availability group. And once a replica receives its request, it will reply back with a healthy copy of the page, and then the other replica will automatically and transparently replace the page. So this saves a lot of headaches for database or these corruption issues because we're automatically self-healing the system. Couple of things here that may be interesting to you. We support full cross feature across SQL Server. So in the past, if you use database mirroring, you know that, for example, we didn't support things like file stream. Right? So with availability groups, every feature that we have in SQL Server, including file stream, contain databases for people who were familiar with that, file table, service router, etc. All of these features are supported and protected by the availability group. So if you're using these features and you're storing, for example, file stream data, this file stream data will be highly available as well to the availability group. If you're using System Center, we also support it. So you can monitor, for example, your availability groups across a large number of servers. Finally, jumping into the active aspect of the secondaries. So there are a couple of things that you can do with your secondaries. You can run read workloads. So if you have reporting workload, for example, like SharePoint, or you have backups, you can start moving these from your primary into your secondary servers. And the reason is that these workloads and these backups take higher resources. They can take CPU resources. And if you want to keep those resources available to your OTT workloads, you can move this outside of the primary into any of your secondaries. And finally, people who are using PowerShell, we support it as well. And we talked about the fast failover before. So this is the final slide before jumping into SQL 14. And this is just so that everybody has the context of how a deployment looks like. So this is a traditional availability group deployment. So what you can see is on the right side, imagine you have your main data center, right? And then you have a couple of servers, always on server 2 and always on server 3, right? And one of them is your primary, right? The one with the blue flag there. And then that primary has one or more databases as part of an availability group A. And then in the same data center, you can have a secondary replica, right? And most likely that secondary replica will be configured as an automatic failover replica, right, to guarantee that you have high availability in case the primary goes down. And then in other data centers, for example, here we have another data center that is close to the main data center. You can have another which is on server 4, and you can use that server for something else. So you can use it besides of just waiting for a disaster to happen and fail over to that server. You could use it, for example, for backups. So companies that require maintaining backups outside of the main data center for compliance reasons can use this technology to take this backup from the secondary and keep them outside of the main data center. The other thing that you can do is you could have another replica, for example, far from the main data center, in this case always on server 5, and you could use this replica to run your reporting application. So if you have, for example, some reporting needs outside of the main data center, you can locate a replica there, and you can start generating your reports from there. Okay. So that was the overview for SQL 2012. Let's jump into 2014 and what are the improvements that we have always on. So just giving you the context of how we're or where we're taking SQL Server high availability. So our goal is to provide the best-in-class solution, which is cost-effective. So that's something that we are trying to maintain. High availability and disaster recovery. So again, those are the two main functionalities that we want to guarantee as part of the always-on technology. And then we want to guarantee this not only for on-premise. I mean, we have many customers running on-premise, but also we want to guarantee this in the cloud. So now that we support SQL Server in Windows Azure Virtual Machines, for example, we want to guarantee that the solution works well, and also for having the scenarios. So now we have started, as I mentioned before, supporting these heavy scenarios where you can maintain one or more secondaries or your availability groups in the cloud. Right? So we want to cover all of these different types of configurations. All right, so going into specifically always on in 2014. So first for availability groups, first thing that we're doing is we're increasing the number of secondaries. And we'll talk about why and how you can use them. We're increasing the availability of readable secondaries. So customers who are using these secondaries for reporting workloads, for example, will find this increased availability super useful, and we'll talk about how it works and what scenarios are beneficial. And finally, we have a wizard in SQL Server Management Studio. So this is a user interface for SQL Server, and we have introduced a wizard to really simplify adding secondaries in Windows Azure. Right? And we'll talk about why you want to do this and what are the scenarios and what are the considerations. And then for SQL clusters, we introduced support for a very popular feature in Windows Server, which is called Windows Cluster Share Volumes. So we'll talk about what are cluster share volumes and why it is important to support them for SQL clusters. And finally, between availability groups and SQL clusters, we have around 30 enhancements with regards to diagnostics. And this is to guarantee that at any point in time, you can quickly monitor and troubleshoot any issue that is impacting high availability. So talking about the increased number of secondaries, we talked about before how we supported 2000, in 2012 we supported 4 secondaries. We have increased that number. Why customers are asking for this? Well, the main thing is customers want to have a single technology to configure and manage, right? So we have, for example, a scenario where customers were using transactional replication to maintain multiple copies of the data, for example, to scale out reporting applications. However, this requires managing a separate technology. So these customers, if they already were using availability groups for high availability, they would like to just be able to expand the availability group and be able to cover more replicas for that. The other thing is availability groups has considerably higher throughput than replication, around 7 times faster. So I'm not going to go into the details of why, but based on our internal testing as well as performance testing done by customers, we have identified how this technology is a lot faster in terms of how much data and how fast you can push the data between the primaries and the secondaries. So these are a couple of reasons of why customers are using availability groups for really scale out the scenarios. The other reason is many customers start to, they have geo-distributed environments where they have multiple offices, for example, in the environment, right? Sometimes these are far apart, and they maintain local reporting applications, and they would like to avoid having to go to the primary replica, right, because of latency concerns. So having these additional secondaries allows you to locate 1 second initial keys, geo-distributed offices, and then read from them. Couple of things. We still maintain the maximum number of synchronous secondaries to 2, right? Synchronous secondaries basically means that the primary will wait to commit a transaction until that transaction is stored by the synchronous secondist. So we wanted to avoid potential performance issues where customers may configure, for example, 8 seconds as synchronous, and then a transaction needs to wait for all of those seconds. So today, we'll still keep the number of seconds, synchronous seconds to 2. So, and that is for high availability purposes. But if you want to use these seconds for really scale out the scenarios, then you can configure all of the remaining seconds as asynchronous seconds. And what this means is transactions will not wait for them to be stored on the secondary, right? How far behind secondaries will be in terms of when the secondary sees a transaction committed for the primary depends on the network latency and I/O. Again, depending on the particular deployment, this can take between less than a second. So within the same data center, normally we see the secondaries reflecting transactions in less than 1 second. Across different data centers, again, it depends on how far the data centers are. But for example, within the States, from New York to Portland, it is around 3 seconds, between 3 and 5 seconds, depending on the amount of workload at a particular point in time. So it's still pretty short periods of time, very minimal performance impact. So for some of you who will go and use, 5, 6, 7 seconds, basically the commits do not wait for these seconds, again, because they are asynchronous. We have a single log pool in SQL Server. This log pool is a cache, basically, for the log records that we're sending to the secondary. And when the primary sends a log record to the secondary, we keep it in the pool, and then the other secondaries can read it from the memory as well. So what this means is we don't have to go and read the log records from the disk all the time. We can basically optimize this. Just giving you a quick number. From 0 to 8 asynchronous seconds, the performance impact on the primary is less than 1%. You can imagine very, very little impact to the primary, and you can go and start scaling out across a large number of seconds. If you're familiar with something called read-only routing, read-only routing is a technology that we introduced as part of Always On in 2012, and read-only routing allows you to route read workloads. So in your connection string, you can specify that your application is going to be doing reads, and then we'll automatically route you to the first available secondary, right? So that behavior is still the same in 2014. Some customers are asking for out-of-the-box load balancing, right? So today in 2014, we don't have it yet. That's something that we are working on. But if you want to do load balancing, for example, between readable secondaries, what you can do is use DNS round robin, for example. So you can create multiple entries in your DNS server with the same name and different IPs of the readable secondaries, and then DNS will automatically do round robin across it. And then we have many customers today that's how they're round robin, for example, reporting workloads across the secondaries. Or if you want, obviously you can always use specialized load balancers. So you could use hardware load balancers like F5, for example, routers, or you can use specialized software load balancers like the network load balancer by Microsoft. All right, so I'm going to show a few screenshots in a moment. Let me talk about this one first. So the other enhancement that we did for availability groups is with regards to readable secondaries. So in 2012, there are some scenarios where the read workloads can be disconnected from the secondary. So the scenarios are, for example, if you have a geo-distributed environment between data centers that are far from each other, and if you have network failures, for example, if network failures are common, right? For example, your ISP provider is not as good as you expected, and then you lose connectivity between the data centers. That can cause your read workloads to be disconnected. And the reason is that in 2012, if the secondary cannot see the primary, it goes into one state that we call the resolving state. Basically, the secondary doesn't know at that point who the primary is, and because of that, for safety reasons, it disconnects all connections. So what we're doing in SQL 2014 is we changed this behavior so that even if the readable secondary loses connectivity with the primary, or if the primary goes down for some reason, or even if all of these secondaries, which today build a quorum, right? So you're probably familiar with how Windows cluster provides something called quorum, and availability rules basically depend on Windows cluster, and Windows cluster maintaining a quorum. So if you lose quorum, in all of these cases, the readable secondaries will still remain available for reads, right? So we have changed the behavior in 2014 so that even if this second is going to the resolving state, connections will still be open, and even new connections will be acceptable, right? And you can continue reading from the readable secondary. In case you want to know, what is the state of the secondary? If, for example, you want to know if the secondary has been disconnected from the primary for some time, we have all of this information available in DMVs, so dynamic management views. You can look at it, and we also have information available in the dashboard. So this is one example. So hopefully you will clarify this a little bit more. So again, we have the previous topology that we talked about before, and in 2014, if you lose connectivity, right, between the data centers, right, and it's assumed that for half an hour, 1 hour, your ISP provider is running into problems, we'll still allow your readable secondaries to maintain active connections and to accept new connections. So any reporting workloads won't be affected by any changes between the data centers. So just giving you just one example here of one of our customers who is using this feature. So Stack Overflow, you're probably familiar with them, a very famous website. And this is one comment from them. The increased readable secondaries availability means all users can still find answers online and the world keeps spinning. So Stack Overflow is the site where you can go and ask questions, and then you can go and read the answers from other people in the community. So in the case of Stack Overflow, by the way, all of this is public, so they are very good at blogging about how they use SQL Server. So you can just go into Stack Overflow, they have a blog, and you can look at all of this in detail. But basically what they're doing is they have the main data center in New York, they have the secondary data center in Oregon, and if for some reason they lose connectivity between the two data centers, they can still use this readable second in Oregon to basically serve the website, so that all of those answers for all of those questions that people are asking in the community can still be reachable through the website. So basically how they're doing it. They use the two secondaries, so we have this one, New York SQL CL01, and then Oregon SQL CL01. So they use one of these secondaries for uploading the reporting workloads as well as the websites. So if, again, they lose connectivity or the primary goes down, all of those websites can still continue working. So you can go online and read more about that. So at this point, let me show a little bit more in detail how this works. So let me, 1 second. All right, so what I have here is SQL Server on 2 screens. So on the left side, I have my primary, right? On the right side, I have my readable secondary. So you can see on the primary, I created a table, I inserted 3 values, and you can see in the readable secondary, I'm reading the values, right? Now you can see that I inserted a couple more values on the left side, inserted values 4 and 5, and you can see those values on the readable secondary. Right? So I can read the 5 values that I have inserted. You can see that the database is in synchronizing state. Right? Now, what I'm going to do is stop the primary. Right? So I have my primary here, rvartel HADR 0. I'm going to stop it. Right? Okay. And now what I'm going to do is stop the secondary replica that was configured for automatic failover. So if you look on the left side, you'll see that now my primary is rvartel HADR1. Now if I stop this, basically what you'll see is I get this error on the primary saying that there is not a connection open to the primary, and this is because at this point both my primary as well as my automatic failover secondary are stopped. So I cannot use those, but you can see that on the right side, my readable secondary can still read from the database. So even if my primary is down or I lose connectivity, I can use my readable secondary. Right? You can look into more detail about what is going on with your secondaries. So in SQL Server, we have this dashboard which allows you to see the health of the replicas. We make it very clear, so you can see we have this red cross. Basically, we say the replica is in resolving state. If you click into the details, we'll basically tell you the availability replica is disconnected. That means you cannot contact the primary. So you very clearly know that you have a problem, but even if there is a problem, you can still use your readable secondaries, right? And those workloads will not be impacted by it. At some point in time, your primary will come back online. In this case, I'm going to start it. So I can go into my primary, just start it. I start the primary, and as soon as the primary is started, the secondary notices the primary is available, and it starts resynchronizing from it. And you can see now that in the dashboard, we show you that the replica is healthy. So the secondary detects that the primary is back online, it connects to it and continues resynchronizing. So all of this is transparent to your applications. And again, the main value is that your secondaries won't see any disconnections. All right, so going back to the deck, we talk about Stack Overflow and the things that it can do. Again, in the case of Stack Overflow, for example, 70% of the workload is reads, and again, this means that they can continue running even if they lose connectivity to the primary. All right, so some of you may still not be familiar with this concept of hybrid scenarios, and again, the idea is try to bring the benefit of the cloud for customers who are running on-premise, right? So we know that many customers cannot afford a disaster recovery site, right? So to have a disaster recovery site means that you have to pay for the site rent, you need to pay for some maintenance of the site, you need to buy some hardware, you need to maintain the hardware, you need to hire some operations people, so it is not cheap, right? However, we know that many of our customers would like to be able to recover in case of a disaster, right? And a disaster may not necessarily be, a flooding, for example, or a hurricane, although those happen, like in the case of Hurricane Sandy. But this can be simple things like your main router, the one that is connecting your corporate environment, may be unavailable. Your ISP provider may fail, for example. So these are things that may be impacting accessing your data in SQL Server. So many of our customers would like to be able to have a cheap solution to maintain copies of the database outside of the main data center. So in SQL 2012, we started supporting maintaining replicas of availability groups on Windows Azure virtual machines. So since last year, we allowed this scenario, and we already have many customers that are using the scenario. So if you go to Microsoft Case Studies and you search for availability groups in Windows Azure, you'll find that some of these scenarios describing how our customers are using this. Anyway, so we allow now to add these replicas in the cloud, and you can use these replicas for disaster recovery. So if your primary server goes down, you can fail over to one of the replicas in the cloud You can use these replicas also to move some of the read workloads. So again, if you have reporting workloads, you can move these into the cloud. If you have the need to maintain backups outside of your main data center, because you have some compliance reasons, you can take these backups on the secondaries in the cloud as well. We allow you to create these replicas in any of the regions where we have cloud data centers. So we're adding regions all the time. So today we have in West US, East Asia, Southeast Asia, North Europe, West Europe, and again we continue adding more regions. In terms of where do you want to locate these replicas, normally it will be based on two factors. The main one is going to be latency. So you probably want to maintain relatively low latency, and when I say relatively low, it's probably below 50 millisecond round trip between your main data center and the Windows Azure region. And this is just to ensure that your secondary keeps up to date with the primary. Another consideration may be political. It's especially, for example, in Europe or Asia, there's some considerations about how far or how close you need to maintain your data. Right? So some of these may come into play. So this is one example of what you can do, right? So you can have your main data center somewhere in the US, you can have your primary and your secondary, and you can add one or more secondaries in Windows Azure virtual machines, right? And we have a wizard now that allows you to do this very quickly. In terms of how much this costs, so you only have to pay for the utilization of the virtual machine and how much data is stored. You can look into more details and pricing by going into Windows Azure virtual machines. So you just search for that and we'll have all the details there. All the traffic that you send into the cloud is free. So all of those transactions that you are synchronizing between your data center and the cloud go for free. We don't have to pay for that. Again, there are some case studies, so if you're curious about how customers are using them, going to the Microsoft case studies site, you can search. We have some examples like Lufthansa, Thomson Reuters, Buffalo Hospital Supply, etc., that are using the feature. Again, I invite you, if you can either download SQL Server 2014 and play with it, or you can go into Windows Azure virtual machines, and you can look into this wizard. So this wizard will allow you to add these replicas in the cloud. We take care of everything from provisioning the virtual machine. You don't even need to provision the virtual machine yourself. We can go and provision it for you, to starting synchronizing transactions between your SQL Server and the SQL Server running in that virtual machine. So we'll take care of all of that for you. I'm not going to go into a lot of detail here. Basically, we have many enhancements on diagnostics. So if you have used availability groups, some of these may come into mind. If not, basically the takeaway here is that we have simplified diagnosing and troubleshooting issues. Right? So this is just giving an example of some of the things that we have done. I'm just going to mention a couple of these so that you get an idea of the things that we're doing. So in SQL Server, we have something called X events, and these are events that track the runtime state of the system. So every time that the runtime changes, for example, every time that a secondary stops synchronizing from the primary, right? We generate one of these X events. And today, before in 2012, we showed this only in the local time of the SQL Server. Now we are changing this to allow us to show them in UTC time. So if you have replicas distributed across the world, for example, and they're in different time zones, now you can correlate all of these X events through UTC time. Some simple things sometimes that customers ask us, but they have a lot of value. We introduce a new function, is primary replica. If you give the name of the database, it will return a Boolean value, true or false. telling you whether that SQL Server is the primary replica for that database. So before in 2012, you had to run a query across catalog views and DMVs. We're trying to simplify it. So the general idea is trying to simplify getting information about the runtime state of the system. We have many of these. So we're going to go into that. If you go into SQL Server Always On in Books Online for 2014, you'll find the list of all these enhancements that we have done. Now, with regards to failover cluster instances, again, for people who are familiar with SQL clusters, we introduced support for a Windows feature called Cluster Share Volumes. And the Cluster Share Volume is a shared disk that is accessible to all the nodes in the cluster over SMB, the SMB protocol, specifically SMB 3.0. And what this allows you to do is to have one or more cluster share volumes per physical drive. And why is this important? So this is important because we want to improve SAN utilization. So today, by default, you have a limitation of the number of drives that you can create with your SAN, and that is the number of letters in the alphabet, that's 24. Some customers work around this limitation by creating mount points, but then they need to go and manage those mount points over time. There's additional management they have to do, so we can really simplify this by just allowing to create cluster share volumes over the physical drives, and that's how you can go and create as many drives or as many share volumes as you want on your physical drives. The other thing is cluster share volumes increases the resiliency of I/O. So every time that there is a read of a write to the storage from one of the cluster nodes, if the read or write fails, the cluster share volume will automatically retry the read or write to the link of another node. Right? So basically, you get redundancy on the read and write at the storage level across the links for all the cluster nodes that are connected to the cluster share volume. Finally, it increases failover resiliency. So before, if you don't use cluster share volumes and you use traditional disks, at failover time, we need to unmount those drives from the previous server that was the primary SQL of the cluster, and then we have to mount those drives on the new SQL server that will become the primary. Those unmounting and mounting operations, in some cases, may fail. Again, there are very, very few cases, but there's still some cases where, depending on the type of storage that you're using, those may fail. So you can basically remove that requirement of mounting and mounting drives by using the cluster share volumes, where after failover, the new primary, all it has to do is connect to the storage, connect to the cluster share volume, and continue reading from it over SMB. It doesn't have to do any mounting or mounting. So again, cluster share volumes improve utilization of the SAN, increases resiliency of the storage, and increases failover resiliency. This is how it looks. So on the top, you can see this is the traditional Windows cluster interface. This is Failover Cluster Manager. So you're probably familiar with this if you have used SQL clusters in the past. So this is the list of disks that we have in the cluster, right? And you can see that I have cluster disk 1 and cluster disk 4, which are cluster share volumes. And then when you go into SQL Server and you install a SQL cluster, you can specify, or you can use these cluster share volumes as available share disks. So you can go and store your data files or log files into these cluster disks as if they were any traditional disks, right? And then you can benefit from all the things that we talked about before. So I have a couple of minutes. Wanted to mention Always On and SQL Server High Availability benefit from enhancements in Windows Server, specifically on Windows Cluster. So just a couple of things that I want to call out. If you upgrade into Windows Server 2012, for example, there are a couple of features in Windows Cluster that will benefit Always On. First one there is a feature called dynamic quorum. So what this means is if one of your cluster nodes loses connectivity with the rest of the cluster will remove the vote from that node, and it will not consider it as part of the quorum. So what this allows you to do is, if you have sequential failures where one cluster node goes down and then another goes down, you can still maintain quorum with the remaining nodes. This enables what is called the last man standing scenario, where you can have your primary, for example, available, and even if the rest of the nodes have gone down in an iterative fashion, your primary will continue running. Multiple network resiliency investments in Windows Server 2012, so it's able to handle more exceptions in network issues. So again, especially if you have geo-distributed environment between data centers, it's always beneficial to move to the latest versions of Windows Server. Finally, Windows Server 2012 R2 really simplifies creating what is called network names. So network names are basically the names that you use to connect to your availability group. This is how your clients, your SQL clients, can connect to your availability group. And it really simplifies it. In 2012 R2, you don't need to have Active Directory to register these names. So today, if, for example, you have some Active Directory permission issues and you cannot create the names because your domain administrator hasn't given you the permission, you can work around that in 2012 R2. All you need to have is access to a DNS server, and then all these names are registered there without having to go through Active Directory. So at this point, I'm running out of time. Let me see if there are any questions that we can take. So let me see. There are a couple of questions here.
Yeah, here, I'll read them to you. I'll read them out, Louis. Louis, if there's a failure on the SAN on always on, does it fail over?
If there's a failure on the SAN, if that SAN is impacting the health of SQL Server, so for example, it impacts your master DB, yes, it will cause a failover. If the failure impacts only a specific user database, but is not impacting the health of SQL Server, it will not.
Are there plans to support for allowing auto failover of always on when there is a LUN failure with the disclaimer of data loss?
There's a LUN failure. Again, depending on what is impacting. So if it is impacting, for example, the health of the server, let's say that you cannot access master, then it will cause a failover there. In the case that there are some corruption issues, for example, on the storage level, as I mentioned before, we will automatically detect those corruption issues and replace those pages. If, however, the failure means that the LUN for a user database is not accessible, but SQL Server itself can still run, that's not going to cause a failover. Right? If there are more questions about how specifically this works, please go into Books Online. There is a page called Flexible Failover Policy, and that will specify, what are the conditions that we look at for the different types of failures to cause a failover.
Can I run availability groups on a multi-site geo-dispersed cluster with a slow link, i.e. 10 megabits per second?
Yes, so there are a couple of questions there. So the first thing is, yes, you can have an availability group between different subnets and different data centers, and that's fine. With regards to the bandwidth, again, the bandwidth consideration comes into play depending on the amount of log that you need to send between the primary to the secondary. So depending on how many transactions you are running per second, that is how much log, right? And you can measure that with a performance counter. So you can look at log generation per second, and then you can see whether that is going to fit or not over your pipe to your data center. So if your pipe is not large enough to push that amount of log, What that means is that the secondary is going to fall behind the primary.
Okay, in regard to a readable secondary, what are the plans to allow for a faster redo process so the data on secondaries are closely same as the primary? What counter in the always-on dashboard can be used to show the delay or number of transactions missing from a read perspective on the secondary?
Got it. So again, a couple of questions. First, with regards to the dashboard and how you can look how far behind your secondary, there are two metrics that are important. The first one is last hardened time. Last hardened time means what was the last time that that secondary stored a transaction in this, and it has a corresponding last hardened LSN, and that is the last transaction log sequence number, right? You can specify at the transaction, even at the transaction level, what was the last transaction that was stored in the disk for that secondary. Now, as the person asking mentions, there is a separate asynchronous process that redoes these log records on the secondary and applies them to the disk, right? And until these are applied to this is when you can see these reflected in the data. So there are a couple of similar metrics that you can look at in the dashboard. One is last read-on time. That is the last time when that secondary apply the log to the data pages, and then similarly last read-on transaction LSN. And that is the last transaction that it applied to the data pages. So you can compare this, for example, with the value for the primary. So the primary again has the last transaction sequence number that it committed and the last transaction sequence number that it sent to the secondary, and you can see how far behind the secondary is. We actually calculate an estimate of this. So we have something called recovery time, right, from the secondary, and that basically measures based on how far behind the secondary is and the speed at which it is applying this log, how far it will take it to catch up with the primary in case that there was a failure at that point in time. So was there another question?
Yep. This is a great enhancement to be able to read from secondaries, even if primary connection is lost. Is there some work down on allowing DBs to be available on an availability group, even if one of them is still in recovery?
Got it. So with regards to this enhancement for the readable secondary, the readable secondary replica will make all of its databases available for reads, irrespective of what happens to the primary or what happens to other secondaries or what happens to the link between that secondary and the primary. So that will still be able to read. So in the primary, even if the database goes into recovery stage or offline stage, whatever the stage it is, the readable secondary is not going to be impacted by that and will allow it to continue reading from it.
Okay. What artifacts are there to, I'm not sure that's the right word, are there to restart the synchronization of an availability group database? It seems to us that once there's a network issue or the like, we have to rebuild the AG to get the secondary available again.
So by default, for the large majority of cases, if the primary and the secondary lose connectivity, when they establish connectivity, the secondary will be able to continue resynchronizing from the primary, and this is transparent to the application. If the secondary has fallen significantly behind, and I need to remember my exact number, I think it's on the order of gigabytes. The secondary has fallen behind more than a second, and I don't remember right now what number of gigabytes is, then at that point it won't be able to resynchronize, and what will be required is to take a backup of the primary, restore it, and then re-add the secondary as a replica.
Is adding a replica to Azure something we can do for free for study purpose?
So yes, and yes for a limited period of time. So if you have a Windows Azure trial subscription, and I think that you can go into Windows Azure and get a 30-day trial subscription, you can try it. You will be allowed to go and create a virtual machine, so you can provision a virtual machine with SQL Server, and then you can set it up as a replica. The only consideration is after 30 days, and you have to pay for it.
Did I hear correctly that Always On requires the use of Azure?
No. So Always On doesn't require Azure. Always On can be and has been used now for almost 5 years, just on-premise without any cloud. However, a year ago, we started supporting Always On replicas in the cloud. And what that means is you can add replicas in Windows Azure to your on-premise Always On configuration.
Okay, the rest of the questions have to do with getting the webinar, getting the slides. My friends, the meeting is recorded. The recording will be posted at dba.sqlpath.org as soon as I get around to it, which will probably be tomorrow. But the last time I posted a recording, it took a long time because I had problems. So I don't promise. If Lewis sends me the slide deck, that will be posted as well on dba.sqlpath.org on the meeting archives page. The meeting recordings are far too big to email, so you'll have to go there to look at them. And I hope you do, because we've got recordings from almost all of our other sessions. And so I thank you for your presentation, Lewis. If you'll send either me or Lana the slide deck, I can see to getting it posted. And I appreciate your contribution to the DBA virtual chapter.
Thank you.